Good morning, good afternoon, good evening. Today I'll be making this electric billboard effect. Not the recent OLED type, but the 1980s to early 2000s incandescent light bulb display type. Though it's probably possible to achieve this look with use of textures, we will be using geometry nodes. Alright, let's get into it. As soon as we get into Blender, we'll hop right into Geometry Nodes Layout, H select all, X to delete, Shift A, add new mesh plane. Using numpad 7 and 5, we'll go into top orthographic view, click on new, delete group input, add a string input instead, and type in something like test, pass it through strings to curve, then output. Alright, so today's effect is electric billboard effect, which we will have some kind of a display right here filled with light bulbs, and wherever it's overlapping, the text is gonna light up basically. And we're not going to have it static, we'll actually have the text move from right to left, like so. Okay? So that's what we're going to do, so let's get into it. We'll first start off by filling the curve. Fill it with Ngon, then realize. Okay? Right. We're pretty much done with the first step of the text, so let's move on to making the board. Right, so we'll just go a little bit above. We'll first off start off by adding a grid, and for this grid we will be setting the size X and size Y externally from a group input. So add a group input, plug in size X and size Y. We want to do this because we'll be using these values throughout this node tree. So I'm going to change the size X to 3, so it's going to be 3 by 1 meter board. And another value that I want to control externally is I want to control the size of the light bulb. So opening up the side panel with N, I'm going to add a new socket, call this bulb radius, and I'm going to set it to 0.005, 5 millimeter radius, 1 centimeter diameter. Right, so from the bulb radius, what I'm going to do is use the mass node and multiply it by 2 to get the diameter. Then from size X, I'm going to use a divide and divide the size X by diameter, and also add 1. Right? This is the number of vertices that we're going to need on the X direction. And also for the Y, I'm going to Control Shift D, the divide and add, bring it down here. Use the size Y for the top socket of divide. Connect the add to vertices Y. If I go into wireframe, now we can see that we have a grid with 1 centimeter in the grid width and length, like so. Okay. Right. Now we can place the light bulbs on each point. So I'm going to use an instance and points. Pop it in here. From instance, I'm going to pull out a mesh circle. And for the circle radius, I'm going to use the bulb radius right here. And change the fill type to Ngon, like so. So now we can see this board is made up of 30,400 light bulbs, and that's basically what we're gonna leave it at that for now. Okay. Okay, just for reference, size reference and position reference, I'm just gonna draw annotation around here like so. You don't have to do this, but this is where the board is located. So now the board is complete, I'm just gonna go back to the text. Okay. Right. So the text right now is placed on top right corner, which is not ideal. So I want to recenter it so it's centered along with the board. I'm going to pull out a bounding box. From max, I'm going to use a vector mass add and add the min. I'm going to scale it with vector mass. Scale it by -0.5 and I'm going to pass it through a transform geometry translation so it centers right here to the center of the board. Okay. Next, what I want to do is match the height of the text and height of the board, like so. Right. So what I'm gonna do is I'm gonna first get more real estate, but grab a bounding box. From max, I'm gonna use a vector mass, use a subtract min from max. I'm gonna separate x, y, z, and this y is gonna be the height of the text, right here. Next, I'm gonna grab a group input, grab the size y. This is the size height of the board, so I'm gonna divide this by the height of the text. Next, use a transform geometry and scale it by the result of divide. Okay. So now you can see the text height is matching the board height. Okay. The map looks kind of like this right now. I'm going to move it over. Right, so now we have the size matching. I'm just going to display it on the board and see what happens. What I'm going to use is a raycast node. I'm going to plug it in after the transform geometry and use this is hit for selection of instance on points, like so. Okay. Alright, and display, and now you can see the text is basically made up of all the light bulbs, like so. It doesn't look well, it looks decent, but I just want to make it so it's more obvious. Light bulb, I just set the light bulb size to 0.02 and now it looks like this. Okay. Right, so if it's static, it's fine, but we want to make it dynamic. We want to make it give it some motion. So what I'm gonna do is set some values so it starts moving, right? But before I do, let me just explain what I'm gonna be doing. So this is a grid of the board. So let's say we have the text right here. What I want to do is when the animation starts, I want the text to be over here, right outside of the grid, and it's gonna start from here, move into the grid, and it's gonna move out and end up over here, just right outside of the left edge of the grid. Okay, so starting point right here and ending point right there. Right, but how do we get these values, right? What do I need to do to get that position? Well, basically if we divide it into half, this amount, the half of the board and basically the half of the text is how much we need to shift the text over by. So just add these two together, we'll get the starting point, and we can use it to just subtract and get the ending point, like so. Okay, so that's what we're gonna be doing. I'm just gonna mark the edge right here, like so. Right. So let's get the starting and ending point. So first I'll grab a bounding box. Okay, it's right before the raycast and between transform and raycast. I'm gonna use a vector mass, use subtract and subtract min from max, use a separate XYZ and grab the X. This is the width of the text. I'm just gonna multiply by 0.5 and get the half width of the text. Use a group input, get the size Y, and apply the same 0.5 multiplication, and I'm gonna add it together. Right. So this is gonna be the starting offset, so I'm just gonna combine XYZ, plug it into X, then using a transform geometry, I'm gonna plug it into translation. Okay. Now we can see the text has moved over here. So before, after. Okay. So we got the starting position of the text. Now we want to get the ending position, which is pretty simple. So what I'm gonna do is duplicate the add, change it to multiply, multiply the result of add with -1, and now we get the ending position, like so. Alright. Okay, so let's make an animation going from right to left, which will make an equation that represents a relation of time with the position. So I'm gonna use a map range, and I'm gonna plug the result into combine XYZ, and from value I'm gonna pull out a scene time, seconds, plug the result of add into to min, starting position, and the result of multiply to max, which is the ending position. And depending on the length of the time that you want, you can make it so it moves over from right to left within whatever time you want. So right now I've set it to 3 seconds, so it's going to take 3 seconds to traverse from starting position to ending position, like so. Okay. But you can set up whatever value you want. Right now, you can see that whenever it reaches the left side, it just stops. But if you want to make it loop around, what you can do is use another mass node. Use the wrap function right here. Plug in a scene time to value, and you have to match these two values with the min max. So it's going to be 0 and 3. And plug it into value, like so. Okay, so now whenever it reaches the left side, it's gonna traverse back to the starting position and keep on going back. Okay, what I suggest is pull out a value node right here and connect it up with max right here. So the from max and the max is always going to be the same. So you can always control this value with single value. Right? So if you want to change it to 5 seconds, this is one single change that you have to make. Right. So the movement of the text looks fine. Let's kind of show it through the billboard. Okay, so now it's moving from left to right with all these light bulbs. But as you can kind of observe, you see that the text shape is kind of changing. It's kind of transforming in the middle. If you take a look at like the side of the E, you can see the number of bulbs that are lighting up changes. And if you kind of leave it at that, it's gonna kind of look distracting. So one suggestion I have to make is add a mask node right here. Change the add it between map range and combine. Change it to snap function. Use a group input from bulb radius, multiply it by 2 to get the diameter, and use this result for increment. Okay. So now this movement is restricted to snapping to the sides of the light bulb. So now the distraction, well, the flashing is kind of gone, right? So without snap and with snap. Okay. So if you don't like how it kind of flashes or it transforms, I suggest you use the snapping function. Alright, so we're pretty much done with the geometry node part. I'll make some materials so it kind of looks like a billboard material. So let's use set material, plug it in at the end, use the default material. I'll pull out a shader editor, get the default material, delete the principled BSDF, and instead let's add an emission. I'm going to change the color to orangish red maybe. I'm going to change the emission strength to 3. Plug it into surface. For the background world, I'm just going to make it completely black. Then for render setting, I'm going to turn on the bloom. Okay. Right, turn off overlay, set it to render view, and let's animate. And yeah. Of course, you can change like the font, or change whatever word that you want to use, and it's gonna work just fine, right? So let's go back and summarize what we just made. So basically there's going to be two, well, this is the overview. There's going to be two parts, which is creating the board part, the grid part, and the text part. Okay, I'm going to just zoom in and show you what we just made from left to right. So here you go. Right, so very simple. It's kind of elongated, but what we are doing is very simple. Very little mass involved. It's just a couple parts, but what we are doing is basically taking a raycast of a text and displaying it on bulbs. Okay, right. That's it. Thank you for watching till the end. We are seeing less and less of these type of displays nowadays, but by adjusting the font, background, and animation, you can also make retro PC display effect as well. Alright, thank you again for watching, and see you next time.